Hello, this is Lee Jun-hyuk from New Beginnings. In this session, I will explain serial communication in a very simple way, specifically focusing on Universal Asynchronous Receiver Transmitter, UART. Generally, when people think of serial communication, they often think of UART and vice versa. UART is used quite extensively, whether it's for communication between hardware and PCs, hardware to hardware, or hardware to sensors. UART stands for Universal Asynchronous Receiver Transmitter in English, and in Korean it translates to Beomyong Bidongi Song Susin. But you can ignore the terminology for now and just think of it as having one pin for sending data to the other side, and one pin for receiving data from the other side. So, when connecting hardware, you connect transmit data, TXD, receive data, RXD, and ground, GND, in a crossed manner as shown in the diagram. Transmit data, TXD, is the pin for sending data from my side, and receive data, RXD, is the pin for receiving data from the other side. Ground, GND, is connected because data is ultimately an electrical signal, so the ground must be connected to allow electricity to flow. In some cases, you might not use both TXD and RXD. For instance, if you only want to send data, you might only use the TXD pin, or if you only want to receive data, you might only use the RXD pin. However, even in these cases, you must always connect the ground. To explain how data is sent and received via Universal Asynchronous Receiver Transmitter, UART, more easily, we can use the game The Rose of Sharon Has Bloomed as an analogy. In this game, the tagger periodically turns around to check if the players have moved. Similarly, think of it as playing The Rose of Sharon Has Bloomed with just me and a friend. I am the tagger, and I turn around every second. Each time I turn around, my friend can either be standing or sitting. If I turn around and my friend is standing, it represents a 1, and if they are sitting, it represents a 0. So if I turn around and see my friend standing, it's a 1. If I turn around and see them sitting, it's a 0. If I turn around again and see them standing, it's another 1. This way, my friend sends me the data 1011. In UART communication, both the sender and receiver must synchronize their timing. Just as I turn around every second, my friend must also either stand or sit every second. If I turn around every second but my friend changes position every 0.5 seconds or every 2 seconds, the data I perceive and the data my friend sends will be mismatched. This synchronization of data speed between the sender and receiver is called the baud rate. Common baud rates are 9600 or 115200. To simplify, if the baud rate is 9600, it means I turn around 9600 times per second, and my friend must match this speed by standing or sitting accordingly. If the baud rate is 115200, it means I turn around 115200 times per second, and my friend must match this speed. It's very simple. Both sending and receiving must be done at the same speed. If UART communication is not working properly, check these 4 basic things. First, ensure that the logic levels and communication voltages are the same between you and the other device. If my side uses 3V, and the other side uses 5V, UART communication will not work. Although there are components that can match the voltages, if you connect directly, differing voltages will prevent communication. Second, check if the TXD and RXD pins are correctly cross-connected with the other side's TXD and RXD pins. If not, communication will fail. Third, ensure the ground is connected. Even if the TXD and RXD pins are correctly connected, communication will fail if the ground is not connected. Fourth, even if the TXD and RXD pins and the ground are correctly connected and the voltages match, communication will fail if the baud rate timing is not synchronized. Generally, if UART communication is not working, checking these 4 aspects will solve most problems. In this session, I explained UART in serial communication. In future sessions, I will also explain other commonly used protocols like Serial Peripheral Interface, SPI, and Inter-Integrated Circuit, I2C. See you next time.